Example 2 in section 4.4 on page 288. In this case, we're going to explore what happens when we have two radicals in the same problem. The problem is the square root of 4x minus 8 minus 1 equals the square root of 2x minus 5. Now, generally speaking, we want to separate radicals from each other, and we want to separate radicals from numbers. In this case, because there are two radicals in the same problem, we can't move this one to either side, because either way it's going to be with another radical. So in this case, we just bite the bullet and we say we're going to go ahead and leave it. This would be the instance in Tom and Jerry where Tom and Jerry would work with each other sometimes because there was a second cat that came along. So normally they wouldn't do that. Normally we would separate them, but in our case we're going to go ahead and leave them just because no matter where we move this one, it's going to be with a radical. So we might as well just leave it where it's at to begin with. All right, so the same thing that goes in how we solve this problem that we did with example 1, we have to square both sides. Now, squaring on the right-hand side is relatively simple. We put a parenthesis around it, we square it. Squaring on the left-hand side is a little more complicated because we're not just squaring the radical, we're also squaring this -1 that is next door to the radical. All right, let's get the easy one out of the way first. When you square a radical, then what's inside comes out. And so over here, we're going to just have it be 2x minus 5. So that part was easy. Over here, not so much, because this is a FOIL that has to happen. All right. And if you think about this, let's go ahead and do this separately and give ourselves some space to do it here. So we've got a radical of 4x minus 8, and then minus 1, and then another radical of 4x minus 8, and then minus 1. All right, so if we do the foiling here, first is the radical 4x minus 8 times the other radical 4x minus 8. And this was x, we'd call it x squared. But because it's a radical of 4x minus 8, it's still a radical of 4x minus 8 squared, much like what we'd have right here. So what comes out of that is just that, 4x minus 8. That's just the f from our FOIL, if you will. Next is the outside, which is radical 4x minus 8 times -1. That's going to give us minus radical 4x minus 8. That's the O from FOIL. I goes similar. This time we're going to go -1 times radical 4x minus 8. And so basically it's the same thing twice. So another minus of 4x minus 8. That's the I from our FOIL. And then finally we have the last, which is -1 times -1. Otherwise known as +1, and that's the L from our FOIL. Certainly, there's some things we can combine here. The O and the I can be combined because there's two of those. So there's going to be -2 radical 4x minus 8. We have a 4x minus 8 here. We have a +1. Looks like the +1 can be combined with this 8, and we can get 7. And so in other words, we can say this is 4x minus 7, and then minus this stuff here. And so really that up in line 1 here is the end result of us squaring it. We get 4x minus 7 minus 2 times radical 4x minus 8. It's a long FOIL to get there, but that's what happens when you have a radical and a number that you're foiling together. All right, now at this point, if you've ever seen Tom and Jerry, as soon as the other cat was out of the way, if there was a second cat in the picture, then Tom and Jerry would go back to fighting each other. And so in this case, what we see is, hey, this radical is the only radical left. And now there's just radicals and numbers. And this radical says, hey, it was nice working with you, number, for a little bit, but now I need to be by myself because I don't like you guys anymore. And so we need to move everything to their own sides. And since this is a -2 in front of this radical, I'm going to go ahead and take this entire radical and move it to the right-hand side and take 2x minus 5 and move it to the left-hand side. So what I'm going to do down on this line right here is I'm going to say that we had 4x minus 7 already on the left-hand side of this problem. I'm going to bring over the 2x, so it's going to be minus 2x. I'm going to bring over the 5, it's going to be plus 5. And then on the right-hand side, I'm bringing the 2 radical of 4x minus 8. And it's now a +2 rather than a -2. We can combine like terms over here. I've got a 4x and a 2x. That's going to be +2x. I've got a -7 and a +5. That's going to be a -2. Equal to 2 times 4x minus 8. Now, if one thing I noticed right away at this step, which is I've got a 2 and a 2 and a 2. I can't divide into a radical, but anything on the outside of a radical I can totally do. So you know what I'm going to do is I'm going to divide everything in here by 2 just to make the numbers a little bit smaller. When I take 2x and divide it by 2, I get just x. When I take 2 divided by 2, I get 1. Over here, I'm just going to have the radical of 4x minus 8. So I made my work a little bit easier to solve this. All right, so now we have to square both sides. Now we already squared both sides once, and so we have committed ourselves to checking the answer. And so I didn't put that check somewhere, but let's put it here just to remind ourselves, once again, we do have to check the answer. This square of both sides causes us to have to check that answer. Now we have to square again because we still have a radical in this particular problem. Doesn't mean we have to doubly check it, but we do have to check it at least one time to make sure that the answer or answers we get are valid answers here. All right, so we square both times. We square both sides again. And in this case, the right-hand side, once again, squares out pretty easy. And let's go ahead and put that right here. That's going to be 4x minus 8. The left-hand side is a FOIL that has to happen. So x times x is x squared. We've seen this, I think, once before. We're going to have a minus 2x for the outside and the inside, and a plus 1 for the last. And if you don't believe me, do the FOIL off to the side, and you will see that that's what it is. Now we need to set this equal to 0 to solve it, because once again we do have a quadratic involved here. And so we're going to have our x squared minus 2x plus 1. We're going to bring over the 4, so minus 4x, and bring over the 8 plus 8. It's going to equal 0. X squared is x squared still, but then let's see, negative 2 and negative 4 makes minus 6x. And plus 1 and plus 8 makes plus 9, and it equals 0. And I think this is also a squaring, a perfect square here. This is actually x minus 3 times x minus 3 as a factoring here, or x minus 3 squared if you like. I'm just going to go with x minus 3 times x minus 3, meaning that just x minus 3 is equal to 0. I don't have to do it twice since it's the same thing, and this tells me that x equals 3. So in the end, I got one answer, and I go, great, that's good, right? I'm done? No, I'm not done yet. Remember, right? We have to check the answer. We have to go back and say, is 3 the answer? Because now we have two possibilities. Either 3 really is the answer, or 3 doesn't check out, and 3 isn't the answer, and the answer is going to be the null set. So now we need to check and see if 3 really is that answer. So let's create a box right here where we'll do our check. All right, in our original, we had 4x minus 8 in the radical. So we're going to have radical of 4, not times x, but times 3, and minus 8. And then there was a minus 1 on the outside of that, minus 1, equal to, radical here was 2x minus 5, so 2 times 3 minus 5. Let's do the right-hand side first here. You've got 2 times 3, 6, and 6 minus 5 is 1, so you have radical 1 here. Over here, you've got 4 times 3, 12. 12 minus 8 is 4, so we have radical 4, and then minus 1, because here's our minus 1. Radical 4 is 2, and 2 minus 1 is 1. Over here, we have 1. So guess what? It does check out. It totally checks here that we have the same answer, as in 1 equals 1 at this point, to get us there. And so we can say for confidence then that yes, indeed, the x does equal 3 as a final answer. But again, it has to be checked. We can't just assume that the answer we get is the right answer. We must go back and check these answers because of the squaring. Now, if we didn't square, if we had cubed both sides or did something odd-powered to both sides, we wouldn't necessarily have to check the answer because odd powers don't require that. We don't create any chaos or any false results with odd numbers. It's only the evens. So if I square or I fourth or I eighth or I 18th, no matter what it may be, if it's even, I'm going to have to check that answer.